Hi friends and my dear students. For the first 15 days, I couldn't be able to take classes for physics and also maths for 12th standard. Today I am going to handle classes for 12th standard in physics. Second volume physics, 8.7 nuclear fission. When we are going to see something about nuclear fission, first we must know what is by fission. Fission. Fission is nothing but when you think about fission, you have to think about the heaviest or heavier or biggest object. When the biggest heaviest object which was bombarded by means of any energetic particle, then it may split it into two or more nucleus. The nucleus, one nucleus, or bifurcated into two nucleus along with some neutrons, along with two neutrons or three neutrons, and along with this process there may be energy radiation, energy may be released. The entire phenomena is called, you have to understand it clearly. This is the heaviest mass nucleus bombarded by any energetic particle. Then the heaviest nucleus are bifurcated into fragments of two smaller nuclei along with the emission of two neutrons or three neutrons with energy released. Energy released. This process is called fission process. This process is called fission process. Now, let me clearly study about the fission, understand the fission process. You have to imagine the heaviest nucleus is called uranium 92 235. This is called heavier nucleus. One nucleus. You have to consider only one nucleus, that is called 92 uranium 235. It was bombarded by one neutron. Neutron is nothing but an energetic particle. Energetic particle, whenever hit the nucleus of uranium 92-235, then it may split it into two smaller nuclei having equal masses, almost equal masses, like barium, and krypton. Barium and krypton. For example, the atomic number of barium is called 56, as well as the mass number of barium is called 141. Here, the atomic number of krypton is 36, whereas the mass number of krypton is nothing but 92. So, if you are adding these two, 141 plus 92, then we get only 3 plus 13, 233. 233. Here, one neutron also added here. One neutron also added here. That's why 1, 2, 34. 234. Here, are thinking like in different way. Suppose, what is the impact? Before impact, you have to consider the total mass of these two particles. That is, one uranium 92 235 was bombarded by one neutron, so that The uranium absorbs this neutron, and the mass number which will be increased in one number, that is called 236 uranium 92. Uranium 92. This is called isotopes of uranium, which is unstable. Which is unstable. It is no longer to be in the excited state. Almost 10 power minus 12 second it may be stable on the excited state. 10 power minus 12. It is excited state, understood, but only it may be stable there only 10 power 12 second in the excited state. After that it may be decayed. Naturally the decay may happen and split it into two nuclei called barium 56 and 141 atomic mass number, plus krypton 36 and 92, plus you have to add here 236. Here when we are adding these two, 141, 92, that's equal to 233. Remaining 3, there is a mass number remaining 3 is nothing but 3 neutrons. 3 neutrons. If you are 3 adding this 233, then it will become 236, so that the mass number which will be equivalent. Here if you are adding these 3, it is called 92. This is a very important equations for explaining the nuclear fission process. This process of nuclear fission process is not only bifurcated into a small nuclei of barium and krypton along with the nucleus or nuclei. There may be ejection of 3 neutrons or 2 neutrons, depends upon the impact of the neutron energy. Here, suppose in case here we are having 3 neutrons with enormous energy of radiation. This energy is not comparatively, when if you compare the energy released in the fission process with the chemical energy, it is far greater than. The magnitude of this energy released by the fission process is far greater than the magnitude of the chemical energy. That is very important concept. The energy released in the fission process is much most valuable than the chemical energy. That is understood. Then there are 90 methods of uranium bifurcated into 2 fragments of nucleus along with the neutron emission, as plus Q also. But commonly there are 2 methods of emission which are happened naturally, almost 99%. The one is called uranium 92-235 impacted or bombarded by 1 neutron. Then isotopes of unstable isotopes 236 uranium is formed, that is called excited state, and it may be in the excited state only in 10 power 12 second. After that it may be decayed, and decay process may happen, and because of the decay process barium and krypton or the 2 nuclei are produced along with the neutron plus enormous energy. This is the first equation, first method commonly happened. Then another method also happened. The second method, uranium 92-235 impacted with 1 neutron or bombarding this uranium. What happened here? Instead of it may be it the neutron which will absorb by the uranium, so that automatically it will the mass number which will be increased, so that it will be in the excited state, or it is not stable in the ground state, it is in the excited state. Okay, what will be here the decay process happen? We got barium and krypton, but instead of barium and krypton, we are having xenon, xenon plus strontium, strontium, strontium. What is the atomic number of xenon? Xenon 92. Xenon is called 54. 54 is the atomic number of xenon, and 140 is the mass number of xenon. Strontium 38 atomic number, and mass number is called 94. Here in this process, only if suppose you are adding these two, 140 plus 94, then 234. Here 236. That means there is only 2 neutrons are ejected. 2 plus 6, 96 plus 140, 236. This is another method. In the first method, there is 3 neutron emission. In the second method, only 2 neutron are emitted with energy released. This is the most common process of decay process which are happened for the uranium. This is a fantastic phenomenon to explain the nuclear fission process. Once again I repeat, when the neutron bombarding the stable uranium or nucleus, or 92 uranium 235, then the uranium nucleus which will absorb the neutron and to be moved in the excited state, increasing the mass of one, called uranium 236 92 star. Star means excited state. It may be excited state only in 10 power 12 seconds. After that, naturally it may be decayed. During the decay process, there are 2 nuclei are produced. One nuclei is called barium, another nuclei is called krypton. And the atomic number of barium 56 and mass number 141. Krypton atomic number is 36 and mass number is 92. If adding these two with 3 neutron, then 236, and here also 236 with enormous energy. This is the first methodology of decay process which have happened for uranium when bombarded by the neutron. Another method, uranium 235 or absorb one neutron, so that it may be converted into uranium isotope and moves to the excited state 236 star 92. It may be stable 10 power 12 second in the excited state. After that, it may be decayed like xenon and strontium. And the atomic mass number 54, 1 and 38. If you are adding these two, 92, no problem. Here, atomic mass number 94 and 140, that means 234. Remaining 2, that is why 2 neutrons are produced. If you are adding 1 into 2 to 96, then 236. This is a fantastic phenomena that we have to explain the nuclear fission process. If you need furthermore Hmm. If you want to convert these energy released in the fission process for day-to-day uses, then we can convert this energy to for the laboratory purposes, or to convert this energy to convert as electrical energy. Suppose if you are converting the energy released by the nuclear fission process, and this energy almost equivalent to 200 200 million electron volt, and it was utilized 200 million electron volt of amount which are released. This is called Q, and it may be used to operating a bulb, operating a bulb, operating a bulb. For example, if you want to operate the bulb of anything, any bulb, any filament bulb, suppose 100 watts bulb, 100 watts bulb, 100 watts bulb, if you are using this 200 million electron volt as a converted into electrical energy, and utilize this electrical energy to operating the 100 watts bulb for 30,000 years, 30,000 years it may be used to lightening this bulb. That's the value of the nuclear energy released during the process of the fission process. This is a very important question for nuclear fission. Now, the next energy released in the fission process. How can we calculate the energy released in the fission process? This is a famous equation to explain the nuclear fission process. Uranium 235 bombarded with neutron 92, 0, 92. 235 plus 1, 236, that is called isotopes. It is unstable. Then it may be converted into barium and pluton and plus 3 neutron plus Q energy. Now, we have to calculate um, in two processes. What are the particles that are participant or reactant to each other before before decay? There are two particles. One is uranium and another is neutron. The mass of uranium is equivalent to 235.045 atomic mass unit. U means atomic mass unit. And mass of neutron, 1 neutron, mass of 1 neutron, it is nothing but 1.008665 atomic mass unit. If you add these two, then you have to calculate the total mass of reactant. This is the particles are reacted to each other. That's why the isotopes of uranium is formed. Then decay may be happened. So we are adding these two masses, then we will get total mass of reactant. That is, we are adding these two, we get 236.054398 atomic mass unit. We have to put the equation number 1. Now, what are the products that are produced after decay? What are the products? This is called first product, second product, and third product with energy. First product means barium. So that mass of barium is nothing but 141.141. Here one actual mass is 140.9177 atomic mass unit. And similarly you have to calculate mass of krypton. It is nothing but not absolutely 92, but equivalent to 91.8854 atomic mass unit. Then mass of neutron, we already know the mass of neutron. 1 neutron is equal to 1.008 multiplied by 3, then we get mass of 3 neutrons, that is equivalent to 3.025. 2599995 atomic mass in it. Now you have to add these three. Then the total mass of products. What are the products that are produced during the decay? These three products. If you are adding these three masses, we get the total mass of the products that is equivalent to 235.829095 atomic mass in it. So now we are clear. This is we have to put the equation number 2. In the equation number 1, this is the total mass of reactant. Before decay, the absorption of 1 neutron with uranium and the total mass equivalent to this value. After decay, the mass which will be equivalent to the second equation. If you compare these two equations 1 and 2, there may be a reactant mass value is greater than the product's mass value. So how much value is deficit? That is called mass defect. The mass defect is nothing but you have to subtract equation 1 and 2. 1 and 2. Subtract 236 and 235 like this. Then we get 0.22503 atomic mass unit. This is mass defect. 0.225303. This amount of mass defect which will be converted into energy. If you want to find out how much of amount of energy released of this mass, then we have to multiply it by the equation of 931 million electron volt. Then we get so that the energy released, the how much the amount of mass defect multiplied by 931 million electron volt, that is equivalent to 200 million electron volt, nearly 200 million electron volt. This is a value that we are obtaining during the process of the fission process. That's why it is a very important question for 5 mark for annual exam also. So that we concluded that when the fission process takes place, the chemical energy, if you want to obtain this amount of 2000 million electron volt, how much tons of chemicals you needed? More than 20,000 tons of chemicals you have to burn out. Then only you have to get such a amount of energy by means of fission process. So that's why I already told the energy released in the chemical process is far lesser than the energy released in the fission process. The energy released in the fission process are much greater than the value of the energy released in the chemical reaction. This is a fantastic equation and the fantastic phenomena that we understand how a smallest single nucleus of uranium bombarded by neutron, this amount of energy is released. Only one uranium produces such a mass. Then when you think about lack of uranium are bombarded by neutron, how much energy is released? That's the thing that we are going to see in the next topic of chain reaction. What is in by chain reaction and how much amount of energy is released. So in nuclear fission is a very important, and which is the causes for the destruction of the Hiroshima and Nagasaki or the invention of atom bomb only because of the nuclear fission process. If you are not invention of the nuclear fission process, are not invention of the neutrons, then you cannot be able to explain the nuclear fission process, so that you cannot construct the bomb, so that the Hiroshima Nagasaki, which will not be destroyed because of the atom bomb. That is a tremendous change in the science in 1939. 1947, Hiroshima and Nagasaki was destroyed, and lakh peoples and two entire villages are destroyed to each other by means of this energy released during the process of atom bomb. Here the energy is released in two-way process. One thing you have to remember, the bombarded neutrons is not fast neutron, but small neutron, small small velocity neutron. Here the fast velocity neutron. This is a small velocity neutron. That's why it absorbs the neutron to convert as the isotope of uranium. The fast neutron was not utilized for the fission process. Only we are utilizing this one. Slower neutrons, not faster neutrons, slower neutrons or small velocity neutrons. That's the thing very important. I hope you understand. You all are clear about the concept nuclear fission and how much of energy is released in this process during the process of the nuclear fission. Thank you, my dear students. If you have any doubt, you have to put your comments, put your question. I will clear all your question, whatever it may be asked to me. Thank you very much. We will see in the next class about chain reaction. Thank you, my dear students.